Good afternoon, everybody, and thank you all for coming to this session, Establishing a Data Perimeter on AWS featuring USAA. The purpose of this session is to provide you with enough guidance to get you started on your own data perimeter journey, which is something that allows you to mitigate risks of data exfiltration and unintended access to your data. My name is Tatiana Itskevich. I'm a Principal Solutions Architect in AWS, and I'm presenting today with Caleb McDonald and Tyler Warren from the United Services Automobile Association. During this session, we will first look at the concepts of data perimeter. We will talk about security considerations that drive the adoption of data perimeter controls. We'll also look at the guiding principles for implementing and operating data perimeter controls at scale. And then I will hand it over to Tyler and Caleb to walk us through the steps that USAA is taking right now to strengthen their security posture with the implementation of data perimeter controls. So what is data perimeter? When it comes to operating sensitive or non-public data, whether on premises or in the cloud, there's certain data access patterns that enterprises want to prevent, such as access to that data by outsiders. Sometimes it's challenging to do at scale, where you have hundreds of developers operating hundreds or thousands of applications that might be accessing that data. You have developers on one side that want freedom to innovate fast, and you have central security teams on the other side that are worried that those developers will accidentally grant public access to data or transfer the data outside of the organizational boundary. So there is this combination of external and internal threat considerations that sometimes lead to security teams inserting certain roadblocks in the development process, whether it's additional manual reviews and approvals or centralization of tasks such as IAM. This approach may lead to decreased developer agility, but it doesn't have to be that way. Instead, we see organizations more and more adopting decentralized approach to ownership, where central teams no longer want to have full control over all the operational aspects of their cloud environment. They actually want to give their developers more freedom to operate within individual accounts. And with this approach, in order to maintain high security bar, security professionals are looking for guardrails that they can use to enforce specific security invariants across the entire organization that will be effective at all times, regardless of actions that are taken by individual developers. You can think of data perimeters as one set of those guardrails that would allow you to maintain business agility while ensuring secure operations in alignment with your regulations. And the concept of a perimeter is not new. We used to building network perimeters on premises with next generation firewalls, intrusion prevention systems, and web proxies to control ingress, egress for our users and applications. And you will keep doing some of that in the cloud for applications that you will be running in the VPCs, in the virtual private clouds, with the use of security groups, NACLs, network firewalls, web application firewalls to prevent network and application layer attacks. Your applications may integrate with services such as S3 as well, and you may have VPC endpoints configured to ensure that that communication between your EC2 instances and an AWS service doesn't traverse the internet. But when it comes to accessing data stored on S3 buckets, within your environment, S3 buckets are not public by default. The AWS account is the biggest isolation construct in AWS, ensures that everything that is created within the account can only be accessible by the account owner. But based on your business needs, you may need to allow cross-account access. Maybe that S3 bucket actually resides in a centralized data lake account, which need to grant access to multiple applications running in individual accounts within your organization. In order to grant that cross-account access, you will be using a combination of identity and resource policy, where if you allow your developers to manage those permissions, there will be probability of those permissions set in a way that may potentially expose your buckets for external use, or allow your identities to access buckets that belong to other accounts. So those human errors may happen, which leads to an importance of IAM authorization controls when it comes to preventing unintended access to your data. So in the cloud, you will be using your standard infrastructure security controls in combination with IAM authorization controls to build that holistic perimeter around your cloud assets. And those IAM authorization controls is what we call a data perimeter on AWS. You can think of it as this firm boundary around all of your resources that first allows you to define what belongs to you versus things that don't belong to you, other companies' AWS accounts or the rest of the internet, and then help ensure that nothing from that boundary that you define as yours, that green box, nothing from that boundary can get out, and nothing from the outside can get in. So what we are trying to prevent here is unintended access to your resources via service APIs, or unintended transfer of data outside of your organization, among other security risks that we will be looking at. But before we look at the specific security considerations, I want you to keep in mind that data perimeters in the overall access management story are not meant to replace fine-grained permissions. So don't mix with least privilege. Data perimeter is not about this specific developer can only access this specific buckets. Data perimeter is about none of my developers should be able to access buckets that don't belong to my organization. So data perimeters are very coarse-grained in nature. They allow you to enforce security invariants across all of your resources and across all of your accounts, helping you more securely advance through your least privilege journey, but they don't replace it. All right, now that we know what data perimeter is at a high level, we know its role within the overall access management strategy. Now I want to talk about where and how to start implementing data perimeter controls in your environment. So I already said that data perimeters is a set of IAM authorization controls that help you mitigate specific security risks. That means that the best place to start is to treat your data perimeter controls as any other security control within your information security and risk management program, which means that you should start with your own threat analysis to identify and analyze risks that your environment is susceptible to. And then, based on your own risk acceptance criteria, you would select and implement the appropriate controls to mitigate those risks. After that, you would monitor the controls to make sure that they are operating as expected and continuously aligning with your business and security needs. This is somehow a simplified version of the risk management framework, where in order for you to successfully carry out all of the steps, it is recommended that you have certain foundational building blocks in place. And I'm not going to spend a lot of time on that because Tyler and Caleb actually will be demonstrating what those building blocks are in USAA and how they allow them to successfully enforce and manage data perimeter controls at scale. But at a high level, in order for you to be able to enforce those coarse-grained controls, it is recommended that you have a very well-defined foundational environment built using the organizational structure that aligns with your security and compliance requirements. It is also recommended that that foundational environment is built and managed using scalable deployment mechanisms so that you can continuously deploy and manage those controls across your entire organization. And like with any other security control, data perimeter control should be incorporated into your operational procedures and people readiness activities. So now I want to take a closer look at each of these 4 steps, starting with assessing the risk, where I will be uncovering specific security considerations that may warrant the implementation of data perimeters. You will be able to use that information to assess your own organization's need for implementation of specific data perimeter controls. And we'll start with imagining that you have multiple AWS accounts managed through AWS organizations. In those accounts, you may have various AWS resources, and I will keep using S3 as a service which you potentially use to store sensitive data that you want to protect. But in reality, it could be any other resource type. It could be SQS queues, it could be SNS topics, DynamoDB tables, and so forth. So let's imagine that a developer creates a new application in one of those accounts. That application needs access to an S3 bucket in the centralized data lake account. In order to grant that cross-account access for the application to operate, a developer goes ahead and modifies the S3 bucket policy to grant access to that application, but instead of granting access to the application account or an IAM role that is used by the application, he accidentally grants access to an external account, maybe mistypes an account ID, or even gives public access to that bucket. So now, potentially, an external identity can access your bucket. For some of you, risks associated with this configuration mistake is well above your risk tolerance. And if no other compensating controls are present, then you can use data perimeter controls to reduce that risk by preventing access by external identities, even if this type of misconfigurations happen. All right, moving on. Another threat scenario is related to data disclosure through non-corporate credentials. Here, let's imagine that that application was successfully configured. Now it's running in your VPC. The role attached to that instance that runs the application has all the proper permissions to access data in the S3 bucket. But maybe a developer needs to introduce changes to the business logic of that application that require additional permissions. Developer starts experimenting with various temporary credentials just to pinpoint the right set of credentials, the right set of permissions to grant. And at some point, instead of using corporate credentials, accidentally exports his personal account credentials into an instance CLI and starts using those credentials to transfer data to his personal account. It also could be an external actor first gaining access to your EC2 instance. Maybe you had that instance running in a public subnet with a security group misconfigured to allow unrestricted SSH access. Hopefully you have other mechanisms in place to prevent such architectural patterns. But if that happens and there are no guardrails in place, now that actor can potentially initiate a data transfer to a location that is not under the control of your organization. So that could be another security risk that your organization may need to mitigate to align with security requirements or to support strategies such as data loss prevention. Another security consideration within the data perimeter framework is unintended data disclosure through corporate credentials. Here you can think of internal or external threat actor first configuring their personal account S3 bucket to allow cross-account access from your corporate account, and then accidentally or intentionally using your corporate credentials to access those resources in the personal account. So preventing developers on premises and applications running in the VPCs from accessing data stores that are not approved by the company is one of the security objectives that is pursued by companies, especially those in highly regulated industries. And data perimeters is one of the mechanisms that those organizations can use to mitigate that risk. Another set of security considerations is related to the use of corporate credentials outside of the corporate environment. Here we mostly think about companies that still heavily rely on network appliances such as DLPs for preventing data exfiltration. And those companies are concerned about their developers taking corporate credentials outside of that network and using them to access corporate resources. When that happens, they are bypassing those network appliances, and companies want to prevent it. Another scenario here could be your developer accidentally pushing your corporate credentials into the public GitHub repositories. External actor gets hold of those credentials and now tries to use to access your resources. So data perimeter controls can be used to prevent that from occurring, even if that initial credentials exfiltration happens. Now, putting it all together on this slide, I want to mention first that not all of the security risks that we talked about apply to you. It all depends on your own use of AWS services, how you implement and operate in AWS. You may have other controls in place. For instance, you may have static code analysis tools, such as Git secrets, that would prevent the publishing of credentials to repositories. But if the existing compensating controls don't lower the risk to an acceptable level for your organization, you can use data perimeters to do that. Data perimeters allow you to mitigate the security risks by ensuring that only trusted identities are accessing only trusted resources and only from expected networks. This high-level objective is achieved by implementing 3 policy types. Service control policy can be used to ensure that your identities can only access trusted resources and only from expected networks, essentially mitigating the risk of your developer using corporate credentials to access their personal accounts. Resource-based policies can be used to ensure that only trusted identities are accessing your resources and only from expected networks. This helps mitigate the risk of an external actor accessing your bucket after its policy was misconfigured to allow public access. It also can mitigate a risk of an external actor accessing your resource using compromised credentials. And finally, VPC endpoint policies can be used to ensure that your networks can only be used by trusted identities and only to access trusted resources, mitigating the risks associated with the presence of non-corporate credentials in your environment. So you see here is that based on the security risk that you're trying to mitigate, you will be selecting an appropriate control and a policy type to do that. But before you actually can codify that control and implement that control, you first need to set your trust boundary. You need to define what that means for your organization. And you normally start with saying that I trust something that I'm in full control of, meaning that trusted identities, resources, and expected networks are identities, resources, and networks that belong to your organization. But due to the nature of managed services, your developers and applications will also be interacting with identities, resources, and networks that belong to AWS. Your trusted partners also may need access to your resources. So when setting those definitions, you will need to account for all of these approved access patterns in your environment. It's also worth mentioning that some organizations also may need to build smaller boundaries within the environment. So instead of just saying none of my developers can access resources that don't belong to my organization, they may need to assert that data that resides in this specific organizational unit, which was designated to hold confidential data, cannot be transferred to an account in a different OU. And data perimeter is something that allows you to do that as well. And Caleb and Tyler will actually demonstrate how they were able to do that in USAA. But once those definitions are set, now you can codify the control. In this table, you'll see all the security objectives that are targeted by the data perimeters, mapped to the policy type and the condition key that allows you to meet that objective. Essentially, a different combination of a resource policy type and a condition key allows you to mitigate a specific security risk. And on the right side of the table, you see I mapped to the security considerations that we talked about. For instance, if you remember, consideration 1 was related to unintended access to your resources after that resource policy was misconfigured to allow public access. So you see that you can mitigate that risk using principal org ID and principal as AWS service in the resource-based policy to ensure that only trusted identities can access your resources. There are main global condition keys, such as principal org ID, resource org ID, source IP, and source VPC, that allow you to restrict access based on who owns the principal resource and network that are involved in the request. For instance, principal org ID can be used to write a policy that denies access unless principal that is making the call belongs to your organization. Resource org ID can be used to write a policy that denies access unless the resource that is being accessed belongs to your organization. And in both of these cases, you will be specifying organization ID, your organization ID, as the value for those keys. With source IP and source VPC, you will be defining your public CIDR ranges and VPC IDs that belong to your organization to ensure that access is only allowed from your company's managed networks. And then you can use principal org path, principal account, resource org path, resource account to build those smaller boundaries where you will be specifying organizational unit ID and account ID to ensure that only those kind of identities and resources can be accessed from within a specific portion of your environment. In addition to that, you will be using condition keys such as principal as AWS service and via AWS service to make sure that you can account for AWS services acting on your behalf in the definition of your trust boundary. So now, when we talked about how you would select a control based on your own threat analysis, we talked about how you would implement the control using these IAM capabilities. Now, as a last step in your risk management framework, you would monitor the control. And this is important for various reasons, one being that the definition of your trust boundary may change over time. You may break relationship with one of your partners. You can introduce new partners into your business. And with these changes, your data perimeter policies will have to change as well. Additionally, your security practices may require you to do the risk assessment and evaluation of your security posture and the appropriate controls on a regular basis, leading you to have to iterate on that process of assess, select, and implement on a regular basis. In addition to that, as a defensive dev, you may have detective controls that you may need to react on, and also ensure that there are no deviations from the implementation of your preventative controls. All right, hopefully that allowed you to build a mental model for establishing a data perimeter in AWS. And now I will hand it over to Caleb and Tyler after that to tell us how they adopted this mental model to meet their own security objectives.
Thank you, Tatiana. Good day, everyone. My name is Caleb McDonald. I'm a cybersecurity architect supporting cloud platforms at USAA. And today we're going to take you through our journey for for developing an AWS data perimeter at USAA. United Services Automobile Association is a financial services company established in 1922. We provide banking, insurance, and advice to our members, and our mission is to empower our members to achieve financial security through highly competitive products, exceptional service, and trusted advice. We seek to be the #1 choice for the military community and their families. So Tatiana did a great job of going over the concepts of the AWS data perimeter, the controls, and how trusted identities can access trusted resources from trusted networks. We want to kind of go over today our journey on data perimeter from two key perspectives. The first being the strategies and considerations that were important for us in establishing a data perimeter, and the second being the solution that we developed to meet those key strategies. So here, let's take a look at the traditional on-premises data perimeter. You can see that we have our corporate data center, and we have that hard external perimeter from our network security stack, and we want to enable things like connectivities from our customers and our members, connections from business-to-business partners, and the utilization of the internet. At the same time, we want to prevent external threat actors from infiltrating our systems, and we want to prevent connections to malicious and unauthorized domains. In addition, though, we have internal security zones or internal data perimeters, if you will. And that may be familiar to those in highly regulated industries such as financial services, healthcare, and government. And some examples of those are your demilitarized zones, production environments, non-production environments, environments that support users, and restricted enclaves that may contain highly sensitive or highly classified data. Now let's look at that same concept from the perspective of an AWS cloud data perimeter. And for us, the key element of establishing that is the use of AWS organizations. And so we look first at the external perimeter. We see the same concepts there of doing the business we want to do, but preventing the unintended access and unintended connections to malicious and unauthorized domains. And for that consideration, going back to Tatiana's presentation, looking at principal org ID and resource org ID allows us to set very solid controls around that external perimeter. But we want to take it one level lower and look at how do we create those same internal security zones. And that's where we implement organizational units, where we can use conditions like resource org path and principal org path that allow us to have organizational units and accounts for our production accounts, non-production accounts, accounts supporting user environments, as well as restricted enclave accounts. And by using AWS organizations and those same condition keys, we can achieve those same level of controls. So there's two key aspects I want to communicate now around what was important with our data perimeter journey. And the first is how we automate security controls across the organization at scale. And the second is how we still empower developers to deliver in an agile fashion to create applications successfully. And so here you see a visual of automating security controls across the organization. We have the process we call an account vending machine. So anytime we go to deploy a new account within USAA, we have automation that deploys two key aspects we call the identity and access management baseline and the infrastructure security baseline. And what we get out of that is a set of preventative, detective, and corrective controls. A few of these that I want to highlight right now are things like our preventative controls, such as service control policies, permissions boundaries, AWS Systems Manager, blocking public access to S3 buckets, and the implementation of attribute-based access controls. Some of our detective controls include aggregation and collection of AWS CloudTrail, enabling service logs for each service that we enable and aggregating those into our SIEM for detection and response, the use of Amazon GuardDuty for advanced threat detection, and then IAM Access Analyzer, which is a great tool for getting detections and alerts when a resource policy shares resources and services with external identities. And finally, we have corrective controls. An example of that is the use of AWS config and Lambda, where if you do have certain misconfigurations in your environment that you want to remediate, you can take automated action to remediate those configurations. So this slide is really speaking to developer empowerment and self-service, and this goes back to Tatiana's slide about the strategic goal of both implementing security guardrails at scale, but also empowering our developers to deliver in an agile method. And so over on the left, you'll see we have an application team. They're going to be deploying a set of services into their account, along with some resource policies that they manage. They'll also be deploying developer-managed IAM machine roles, as well as developer-managed permission policies around those roles. And so the first set of controls that those developers will go through is our build time controls. We enforce infrastructure as code and continuous integration, continuous delivery in our test and production environments. And this allows us to implement things like infrastructure as code modules and components, where we can bake in secure config into those modules. We also have security scanning of our infrastructure as code to detect if any misconfigurations do happen to find their way into the environment. We run vulnerability scanning into our pipelines, as well as code security scanning and code quality analysis. On the right side, you'll see our security team, and they have to deploy across those same build time controls. And in addition to all the guardrails that we saw in the previous slide, they will also be deploying security managed permission boundaries, which allows us to set the maximum level permissions that developers can deploy on the IAM roles and permission policies that they manage. Finally, we have our infrastructure operations team, which deploys key network capabilities for us, including the centralization and deployment of infrastructure-owned VPC endpoints and the VPC endpoint policies as well. So we just discussed our strategy around data perimeter, the type of zones that we want to create. We looked at our guardrails and developer empowerment, and it became evident pretty quickly that for us to be successful, we would have to have event-driven automation to really succeed at this goal at scale. And so just a couple of interesting data points we had. We have over 100 accounts. Depending on how much activity we see in a lab and dev environment, we may see over 750,000 assets at any time, over 100,000 IAM assets at any time. And we're seeing our cross-account needs growing. We're delivering more and more into the AWS platform at this point, and we're seeing more shared data sets that need to be accessed by multiple applications. Finally, very obvious statement that manual dependencies affect timelines, and we know engineering headcount is finite. Security teams and security touches everything in the cloud, and for us to be able to scale out our security operations, we need automation to address important solutions. So the next step in our journey was asking ourselves, where do we start? There's multiple facets of the AWS data perimeter, and we knew that there are multiple ways to approach them. So we started with our cloud governance framework. Our cloud governance framework at USAA essentially works in any time a new application request comes in, the application owner and architects bring that request to the cloud governance panel, and that cloud governance framework has the objective of ensuring that everything we enable is compliant and secure. We have multiple control owners that are involved in the governance process, to include examples like data, architecture, operations, information security, and privacy. The result of the process, once the application is approved, it goes through the account vending machine deployment that we saw earlier. And part of the result of that deployment are some key metadata tags on the account. Things like an application ID that let us know what line of business this application supports and the criticality of this application to our business functions. Cost center, so we can have bill back capabilities. A unique governance ID that ties to the governance record and the approval process, as well as, very importantly, a data classification tag. This lets us know the criticality of the data, sensitivity of the data, and how important it is in our environment. Continuing on with the question of where should we start, we want to take a risk-based analytics approach, and we wanted to have really data-driven decisioning on where we invested our time and resources. So continuing on with the data classification tag, the first thing we did was run analytics on what data do we have in production, what's the sensitivity and classification of that data, and which data stores contain our crown jewels. Next, we ran analytics on the identities that have access to that data. What are those identities doing with the data, and what do the standard transactions look like? And both that information set really fed a really important step for us, which was threat modeling our overall scenarios, looking at what protections do we currently have and where is our greatest risk, and are we at greater risk from external or internal threats. And a lot of that's really going to depend on your own AWS environment, what your security operations look like, what controls you implemented, and where you feel you have the greatest room for improvement. Tatiana did an amazing job of covering the different threat scenarios in her place in the presentation, and that is an excellent place to start for looking at the different flows that you could be affected by and where you may have gaps. The result of that for us was the scenarios of unintended data disclosure through both corporate and non-corporate credentials, knowing that was where we wanted to focus and that VPC endpoint policies would likely be our starting place. So a couple of interesting data points here is of our API calls that were crossing organizational boundaries, 85% of those were to S3. And of those S3 calls that were crossing organizational boundaries, 70% of those are to AWS-owned buckets and 30% were to vendor buckets. So with that said, we decided that our chosen starting point would be VPC endpoint policies for Amazon S3. In this example, we have some application services running in a VPC. We see the data flow where the data is crossing a VPC endpoint. We see the policy and the condition keys being enforced on that endpoint as a solid preventative control. And to the right, we see examples of the things we want to allow as well as prevent. So we want to allow things like local, connections to the local accounts S3 bucket. We want to allow connections to S3 buckets in the same security zone for shared services and shared data sets. And then we want to allow connections to authorized business-to-business partners S3 buckets. At the same time, we want to prevent connections to malicious and unauthorized S3 destinations. And we want to prevent any connections that would be crossing our internal security zones as part of data perimeter. I also want to touch on a couple of scenarios where the data flow will not use a VPC endpoint. It's highly important to know where your data flows, what they look like, what network connections they go over. And so here we have 3 examples. The first being by default, cross-region requests will not use a VPC endpoint, though AWS does have architectures that support keeping cross-region requests within the Amazon network. The second being AWS services with no VPC endpoint. Those are not going to traverse a VPC endpoint, of course. And then finally, non-AWS destinations. All 3 of these scenarios are going to take a route out of your VPC across your network security stack. And so be aware of those flows and plan to have defense in depth where you're implementing the same protections across your network security as well. And finally, we kind of have a very high level look at our solution. VPC endpoint policy for Amazon S3, kind of a defense in depth look at that. So over to the left, we have our infrastructure operations team deploying VPC endpoints through our build time controls with a lot of preventative controls built in. Inside the VPC, you see the VPC endpoint deployed with enforcement on the VPC endpoint policy and our condition keys. And over to the right, we have CloudTrail. We've actually done some work to enhance our logs and telemetry to give us better visibility and indications when we're crossing organizational boundaries. And we have a corrective aspect of the solution as well. So that kind of concludes the strategic aspects that we wanted to implement as part of the AWS Data Perimeter. And at this time, I'll turn it over to my colleague, Tyler Warren, to go over the solution we implemented to support these strategies.
Thanks, Caleb. Hi, folks. My name is Tyler Warren, and I'm a security engineer at USAA focused on public cloud. and I'm here representing a couple phenomenal engineering teams that helped contribute to this effort. Caleb did a great job of detailing exactly why we started with VPC endpoints. One of the questions we quickly started asking ourselves is, in an organization as large as USAA, with applications deployed across multiple lines of business, how do we know what data is flowing over each of those trust boundaries, whether they're internal or external? And then based on that, how can we actually implement restrictive endpoint policies that also allow our existing applications to continue to function as expected? And so one of the first things we did was we started enriching all of our CloudTrail data with metadata about each of our accounts. All that account metadata is held in a Dynamo table. In fact, there's a great blog post done by members of the team that really serve as an example of how we are trying to platform and productize a lot of our internal security tools. As part of that enrichment, you see some metadata that touches back to some of the governance processes Caleb alluded to with your governance ID, your data classification. We also have some metadata that ties back to the account vending and management pipelines as well. And at the bottom of the example, you see a diff org tag. Now this tag denotes data that belongs to USAA that's leaving our organization destined for a trusted partners bucket. We have similar tags that we use that depict cross-account and cross-environment movement of data within our organization. And it's with all of this additional data, we can see in almost real time how data is flowing over each of those trust boundaries. And so it opens up the possibility for new custom detections. If we know data is only supposed to flow in one direction or to certain vendors, and we see something that's outside of that scope, we can stand up a case and investigate. It also provided a much richer telemetry set for which we could start doing research into the policies that we needed to implement and wrap around each of our applications. And that's where we started. Now, at USA, we use two types of policies. The first being what we call a custom policy. Custom here denotes a specific access pattern that's required by a single use case or a group of very similar use cases. And as Caleb touched on earlier, 30% of our cross-organizational calls went to trusted vendors, with the remaining 70% to Amazon-owned buckets for things like the CloudWatch or the SSM agent. And in this example, you see how we're restricting access to principals in a specific OU to two trusted vendor buckets. Again, the idea here is really hardening that external boundary and being very explicit about the external resources that our principals can access. That second type of policy is what we call a baseline policy. Baseline here means that no matter your application's use case, you're going to need access to certain resources, whether they're AWS-owned resources, maybe resources in shared buckets. And in our experience, nearly 90% of our cross-environment calls were concentrated among a handful of buckets, primarily for grabbing agents that we install on VMs. And in this example, you see how we're limiting principals in a specific OU to resources in the same OU, resources in maybe a security OU, and resources in a shared services OU. Again, the idea here is really taking those internal boundaries and hardening and only allowing explicit access to the resources that your application needs. One other thing I do want to point out is that in addition to these conditions, we also use a lot of the conditions Tatiana detailed as well, specifically resource org ID, principal org ID. And in fact, there's a great blog post, a great open source repo that's owned by AWS that has a bunch of great example policies, and we use them to really get off the ground. Now that we have these policies in hand, how do we actually operationalize them at scale to meet USA's needs? And we approach that problem in 3 points. The first is, how do we create, review, and inventory these policies? How do we take those policies and apply them to the thousands of VPC endpoints across our org? And then finally, how do we ensure that every endpoint, whether it's in a new account or an existing account, is always using an approved policy? And so on that first point, you see a diagram here of how we go from pull request to an outputted policy in AWS. Caleb mentioned self-service. That's an ethos we believe very strongly in at USAA. That is true here. We allow any developer to create a pull request into this repo. We feel that not only enhances agility, it also takes the burden off of security to have to craft each individual policy for each use case. As part of the pipeline, we actually combine that custom policy with the baseline policy. And that's really powerful because we can update a baseline in one place, say we're adding integration with a vendor or removing it, and that can be propagated out to every endpoint across the organization. So it really allows us to scale the integrations in and out as we need. We also take advantage of a lot of the build time controls that Caleb alluded to earlier, things like IAC config scanning, vulnerability scanning. We also use Access Analyzer here, and although it doesn't yet support the analysis of endpoint policies, we use it for grammar and linting. When it comes time to review a policy, our security team steps in. Now, we've been very prescriptive about the access patterns and how to implement those access patterns with development teams, and assuming they abide by those patterns, we can typically review policies in a matter of minutes. So it really helps standardize a lot of our processes we have. When approved, that policy is outputted to S3, and that S3 bucket serves as the source of truth for all of our endpoint policies. And finally, once an access pattern is approved, we can take that new pattern and update our detection stack. And it really allows us to evolve our detections as the requirements of the business change. Now, once we have the policies, how do we apply them? Well, any updates to a policy trigger a Lambda function. That Lambda function grabs metadata about the account in question from that same Dynamo table. It then assumes a role into the appropriate account and applies the policy. Whether we're changing a single policy on one endpoint or a policy on every endpoint across the organization, we can propagate changes in a matter of minutes with this pattern. It also supports any AWS service that supports VPC endpoints, as well as any endpoint services, whether they're internal or external. And so as we add new services and allow application teams to consume those new services, this workflow can help scale there as well. Now, our controls would not be complete without the ability to ensure that every endpoint is always using an approved policy. Caleb mentioned the account vending process. We have our infrastructure operations team stand up all the networking components in a new account. That, of course, triggers a CloudWatch log event. That log event, we use Event Bridge rules to trigger an express workflow. That workflow grabs the appropriate policy from the the centralized bucket and applies it to the policy. This is 100% event-driven. There's no humans in the loop. And due to the nature of express workflows, it's extremely performant. This also is decoupled from all of the external workflows required to manage an account. We have our information security teams standing up an account. We've got our operations teams creating all the networking components. Of course, you have the application team in the account creating the actual application. This does not stand in the critical path of any of them. And finally, if there's ever a time where we see an out-of-band change to a policy, this workflow is triggered and it reverts those changes back to the approved policy. So we've built in automated corrective controls that ensure USAA standards are always met. Now, we've delivered a lot of value with this solution in a couple ways. As we mentioned, we have the ability to update our detection stack continuously as the needs of the business change. We also have telemetry set, which we can do research on further AWS services we wish to utilize. We've also allowed for faster iteration teams for all of our stakeholders. Our application teams can now measure the time that they're blocked in minutes as opposed to hours or days. And we've also given time back to the security teams. No longer do they have to embark on the cumbersome, manual, error-prone process of actually applying policies to endpoints. And we've also delivered controls that scale, that can meet the needs of the business today and in the future. USAA just celebrated its 101st anniversary, and yet despite being over a century old, we are what many would call cloud first now. And so as the amount of applications that we migrate to AWS continues to increase, and as the number of AWS-based vendors that we're asked to integrate with continues to increase, this workflow and our solution can help accommodate all of those needs. Now, we've learned a lot in this journey, and so whether you're just starting your data perimeter journey or you're in the midst of it, there's a couple points and lessons learned that we'd like to share with you. The first is establish the zones of trust that matter to you, that are context specific to your business, and determine the who, the what, and the where for your data. Again, we leaned very heavily on telemetry, and it was a great starting point that allowed us to create policies and get off the ground. Start small. Tatiana mentioned a lot of the threat vectors and ways to mitigate those threats. Wherever you start, whether they're endpoint policies or resource policies or SCPs, focus on one of them and focus on driving business value there first, as opposed to trying to do them all at the same time. Over-communicate with your stakeholders. Given the blast radius of restricting access with VPC endpoints, it's imperative that you reach out to your stakeholders and ensure that they understand the business value and the reasons why you're implementing your controls. We were very proactive in that regard, and we felt it helped drive buy-in from all of our business stakeholders. Now, as you roll these policies out, please do it progressively through your non-production environments before you get into your production environments. We allowed for burn-in time, whether days or weeks, for each level, and we allowed application developers the ability to validate our changes. Trust me when I say, due to the quirks with how AWS principals work in your accounts, maybe some quirks with how you authenticate with vendors, you're probably not going to get it right the first time. That's okay. So when you get it wrong in non-prod. Think about scale and agility from the start. How quickly can you roll out an integration across your org with a new vendor? If the vendor is compromised, how quickly can you roll that integration back? Thinking about scale and agility from the start will really allow you to stay in control of your most prized assets. Align on each of your controls. This is probably true for any security endeavor you undertake, but draw the thread between the preventative controls that ensure proper configurations, the detective controls that highlight misconfigurations, and the corrective action to take when your preventatives are bypassed. This really will help you level up your security posture. And finally, and maybe most importantly, really view this effort as one more layer of your defense in depth strategy. Caleb talked about how cross-region calls go over our on-prem security stack. That's part of our strategy. What you see here today is part of our strategy. It really requires top-down leadership buy-in, both on the technical level and on the business side to be successful. And with that, I'm going to turn it back to you, Caleb.
Thank you, Tyler. So finally, our last slide. We've talked a lot about VPC endpoints and data perimeter, and just want to leave with some thoughts on, well, what about data perimeter for resources? And so there's some really great tooling and solutions that AWS has to help you protect your resources, and there's some unique challenges with resources as well. So let's start about what's available to us today. IAM Access Analyzer is an excellent tool for having detections and alerts when a resource policy has shared that service with an external identity. Make sure that you're integrating those detections into your SIEM and your security incident response process. Make sure that you have playbooks spun up and you know what to do, no matter which security team is responding to it, when one of those access analyzers for a shared to an external identity pops up. In addition, with things like AWS config and Lambda, you have options to take corrective action on those resource policies to either isolate the policy or revert back to a baseline policy. Tyler spoke to testing that in in non-prod, and that's absolutely advice there. Corrective action is awesome, but it's easy to cause an outage as well. So, vet those capabilities in non-prod. Quickly though, some things that are different in our observations is, VPC endpoint policies and the VPC endpoints, they're fairly static. We deploy them. Once we deploy them and set the policy, outside of maybe updating the policy for an exception, they're not touched very often. We centralize it with an infrastructure operations team as well. Resources, on the other hand, with resource policies are extremely ephemeral, especially in your non-production environments. They're spun up, they're spun down, created and destroyed. And so there's a lot more activity around resource policies. If you're enforcing things like infrastructure as code and CI/CD, much easier to bake in preventative baseline policies. But if you have console access, either in your non-prod or even prod environments, baking in those preventative policies becomes a lot more challenging. Furthermore, things like adding policies for network sources, vendors and B2B partners coming from public networks, we're seeing more and more partners come from large range CIDR ranges in public cloud platforms that tend to be dynamic in nature, that can change over time. So unique challenges there, as well as listing out your source VPCs or VPC endpoints. Depending on the size of your account and the number of VPCs you have, keeping track of those source VPCs can also introduce some challenges. Furthermore, due to the ephemeral nature of resources and how often they're spinning up and spinning down, whatever solution that you do approach with, be sure to performance test. We'll see a lot more events, a lot more action being taken place, and keep an eye on your cost as well for those solutions. So that concludes our presentation on USAA's AWS data perimeter journey. Thank you so much for your time, and hope you have an excellent rest of your conference. Thanks.